Greetings, hello, and welcome to my presentation of basically an update on the Deuce model I call the Double L. LL stands for long leg, just to differentiate it from the other models that I used for home gas use. This one's intended to be a torch eventually. I don't have the torch right now, but gotta have the system first is what my opinion was, and then worry about that later. But also supplementation for my van. So this has 52 neutrals per cell pack. It's got 2 cell packs. I'm only operating on one right now for demonstration purposes. This one on this side. And I've struggled to find a control system for it because this is designed to run on 120 volts. So the idea is take your 120 volts from your wall and put it through rectifiers, which turns it to DC, and we have water electrolysis, and lots of it because there's a whole bunch of plates in there, lots of surface area, and the 120 volt works really well for electrolysis. So the trick is a control system, is how to throttle it. You can't just have it blasting full blast from the wall. You have to have some means of control. So at first I had tried things I had read about which were interesting, which are called SCR controllers, silicone controlled rectifier. So here's another sample. So my intention was, I had this set up, these two SCRs in this box, and one was for one leg and the other circuit was for another leg, and I'd created 2 bridge rectifier arrays with 3 pack, and here's another one here. Put a lot of work into that, fired it up, and it kept tripping the breaker in the breaker box in the house here. So I was like, okay, it's drawing a lot of power. So I gave up on trying to run 2 circuits. I just went with one, and I could have medium performance, and I was super excited because the amount of gas created was awesome. But the cell itself heated up quickly, the SCR heated up really quickly, and the bridge rectifiers heated up really bad. So something was not right. These are not appropriate for this application. So Mr. Wiseman, in his book about building a Brown's gas machine, talks about capacitor resistance power supply. So I went all out and made a nice 8-pack of 40 farad capacitor sets that basically let 1 amp through per each one. They're like valves. They operate that way. But I was disappointed. Maybe I didn't have it hooked up right. I just kind of gave up. I was like, well, I don't know. And I went back to just one SCR controller and 1 cell operating. And I was like, well, if I have to, I can run it that way for now, see what else. Then I do some more researching. I come up with this simple, they call it pulse width modulator. So that's different than the SCR. The SCR is silicone controlled rectifier. Pulse width modulator is basically an incredible switch that turns the electricity on off, on off, on off, on off really, really fast. And so with that you can actually throttle something. So this is 120 volt AC. So from this I'm using 2 bridge rectifiers, just the 2 on the ends. I'm not using the one in the middle, just using 2, and then I got that just temporarily hooked up to the wires going to the cell, which is the left one there, and just giving it a try. So this switch box itself, if I were to click it to the left like that, is variable, which means I have control now with this potentiometer. Okay, so nothing's really happening. I'm deliberately doing that. Middle is off. If I go that direction, then I turn it on full blast. This isn't involved. So if I just turn it on full blast, and then we see what happens. So obviously I've already tested this and I was super happy. Oh, these are other things that I had made to control individually each of the capacitors. I had made a switch panel, all that stuff that was also mounted in here. So this project box here has been modified like 3 different times, and gauges and temp gauge and all that stuff, little transformer to run the gauges, all kinds of stuff I've been up to. So anyways, a fan circuit, there's temp circuit, then there's another wire for fan circuit. The fan circuit was going to be these boots that the cell can actually just sit in. So I could take one of these boots, set it on the ground, and then just plop the cell into it. That'd be just whatever, temporarily. You can move it around. I can use the boots for other cells as well. And it just had a 12-volt fan in there. And yeah, so there's a lot of stuff waiting to go here. It's just I needed a reliable control system. So the SCRs were a fail. I pretty much chalked them up as a fail. And then the capacitors were a fail. And I don't give up. So finally I grabbed one of these little boxes, and it claims that it can handle 15 amps AC, and it can run high intensity devices like AC motors that are under load and all that stuff. So I thought, alright, I'll give it a go. Okay, so here we go. So it's going from the wall. It's a dedicated circuit that I have running from the basement. Dedicated circuit to 2 bridge rectifiers out to the cell. Here we go. Alright, get a good shot here. Now all I'm going to do is click it right to full. Here we go. So that's one cell on the side there. And during my previous test I was mucking around with this, and the most amazing thing, I'm super happy about the production there. That is absolutely incredible. That's just one side. So the potential here is awesome. And the best part is that this machine, or this little box here, is not getting hot. The wires are not getting hot. The rectifiers are not getting hot. And the cell isn't even getting hot. Whereas in before, everything was heating up so fast. The SCR would heat up, the rectifiers would heat up, even connections were heating up. So what I've theorized is the type of current coming out of these guys is really troublesome, because one side has the sine wave and one side's flat. And then I was putting that into rectifiers. So that was always a question in my mind. Basically I've come up with the answer. Don't do that. It doesn't really work well. So this is a clean source of current going through here because it's properly done. Whatever the circuitry in there is really nice. And this is full tilt and holding it. Absolutely sustainable. Absolutely incredible production. I'm super happy about that. And this is staying really cool. Wow, you can hear it. So yeah, that's amazing. And look at that. Holy. Wow. That's incredible. Okay, so I'm super happy about that. Of course, more testing to come, and you know, maybe another one of these, and to control the other leg. And these guys still staying cool. Well, you can't leave your finger on there, but that's actually normal for these things. They do get hot. That's why they were set up like that, to be convection cooled. So they do get hot, but before oof, you know, they were getting real hot. Right now, that's not bad at all. That's normal. So that is incredible. And click it off. Click it variable. Turn that up. So we're full blast, I think. What's going on? Oh, here it comes. There was a delay. Look at that. Now, if I turn this down to medium, for example. There it is. It's controlling it. Turn it back up. Alright, thanks for watching. So, can't wait to get that in the van, see what the van does. Oh boy. Alright,